My name is METİN Arıdaşır. This is 152nd part of explanation of my theory. Arıdaşır. I predicted multielectron lithium atoms spectral lines. Here, first page. I hope you see. Left side, according to my theory and my formulas, my computations, lithium atom spectral lines. Right side, NIST data, National Institute of Standards and Technology, Physical Measurement Laboratory. Right side, experimental figures, measurement figures. Right side from NIST data. Left side, here my prediction. This is first page. I advise you to line by line notice. This is first page. Here. This is second page. I hope completely you see. Yes. Right side, NIST data. Left side, my computation. Here, third page. For lithium atom spectral lines. Okay, right side, NIST data. Left side, my computations. Line by line, compare, please. Here. I hope you see completely. Then, fourth page. Here. Right side, NIST data. Left side, my computation. Okay. Yes. I predicted multielectron lithium atoms spectral lines. Lithium atom have 3 protons and 3 electrons. 1. Most common wavelength radius size free electron motion forms in our universes, which are constituent parts of all known ordinary atoms, are initially lambda n is equal to 1 equal to lambda normal, remember from my former videos. Lambda n is equal to 91 point approximately 155 nanometer. This is a kind of wavelength size, radius size electron motion form in our universes, and most common in our universes, and all known ordinary atoms are initially most common wavelength size free electron motion forms in our universes, which are constituent parts of all known ordinary atoms, are initially lambda normal is equal to 91.155 nanometer wavelength radius size electron motion forms. Two, when they are free if 1 of lambda n is equal to 91.155 nanometer size electron motion forms coincide, meet with a single proton, they make joint motion. This is single proton, say upside, downside, no, it's not important. And here, 91.155 nanometer wavelength free electron motion form. When they make joint motion, here, from now on, this is proton, this is lambda n is equal to 91.155 nanometer wavelength size electron motion form, proton-bounded electron motion form from now on. In these conditions, lambda normal is equal to 91.155 nanometer wavelength size electron motion form's wavelength doesn't change. For single protons joint motion, making joint motion, free electron motion forms 91.155 nanometer wavelength normal size, initial size doesn't change. Okay. Yes. From now on it is proton-bound electron motion form. From now on this is hydrogen, you know. And unless disturbed by effects of free electron motion forms successive waves which come from outside, or unless high changing in pressure in medium, this electron stays its first cycling without enlarging, without changing its radius. Now 91.155 nanometer wavelength of undisturbed proton-bound electron motion form has corresponding 21.8 10 to the minus 19 joule ionization or imbalance or ground state energy. 3. Protons can make joint motion side by side in an order, like this. This is one proton, upside. This is its motion arrow, its axis. This is P1. Then downside, this is second proton, entangled. Say this is P2, connected. Then here, naturally, opposite direction, upside. Okay. Motion arrow. This is third proton. Protons can make joint motion side by side in an order. We can say these protons are entangled and they are constituent parts of multiproton. Okay. Yes. 4. In multiple proton structure, without each proton cycling linear velocity changing, without changing their linear velocities 100, remember 6.28 fold greater than speed of light, linear velocity of an electron motion form or protons constituent parts electron-like motion forms linear velocity. Yes, in multiple proton structure. Without each proton cycling linear velocity changing, their frequency must be changed when they entangled multiproton. Then, this changing must affect each of free electron motion forms in 91.155 nanometer initial wavelength size come to connect with each proton. Now, here, say this is one proton, first proton, second proton, third proton, okay? Here, an electron motion form comes to connect 91.155. But when this free electron motion form, which is 91.155 nanometer wavelength, connected with one proton, each electron per one electron per one proton, always. Each electron for each proton, or vice versa. When connected here, this is electron motion form, first electron motion form that connected first proton, say. Okay, joint motion, remember. First proton always shrinks at the rate of squared of wave number. Yes. Wait a moment. This changing must affect, yes. 5. First electron which comes to connect to first proton always shrinks at the rate of squared number of protons in an atom accordingly Arıdaşır's main formulas. 6. But then second, third and the other electrons shrink or enlarge in different wavelength sizes because of their intertwined positioning in accordance with their inner adiabatic medium's effects. And each proton-bound electron motion form connected each proton is now has a new in balance ground state or ionization energy corresponding to their resized wavelengths. For example, lithium. Yes. Here, one proton, first proton, second proton, third proton, first proton or first proton, it's not important, right or left, second proton, third proton, upside say, downside, another upside. When 91.155 nanometer normal initial free electron motion form coincide this first proton, how much proton here? 3. At the rate of 3 squared. Inversely proportional is equal to 91.100 divided by 9, yes, is equal to smallest electron motion forms wavelength we find, nanometer here. This is smallest. This is new initial imbalance ground state wavelength of proton-bounded, first proton-bounded electron motion form. Okay. But second one, 16.38 nanometer here for lithium. Here, second proton bound, here, left side, and its wavelength is 16.38, say. Then, for third proton bound electron motion form resize 229.9 nanometers, so large. Okay, so big, so large. Third electron, like this. Say, or like this. Like this, okay. Then, no. But then, second, third, etc. electrons shrink or enlarge in different wavelength sizes because of their intertwined positioning in accordance with their inner adiabatic mediums effects, and each proton-bound electron motion form connected, each proton has a new imbalance ground state or ionization error corresponding to their resized wavelengths. Each resized electron has different ionization energies or ground state energies and undisturbed now. Okay. For example, wait a moment, please. For lithium, 5.39 EV for 29.90 nanometer wavelength, and 75.64 EV for 16.38 nanometer wavelength size, new in balanced wavelength electron, middle electron we say, and smallest one here, 122.45 EV, corresponds 10.1283 nanometers, smallest wavelength, highest ionization energy of lithium. Now, I hope you understand, okay? And yes, wait a moment, please. Wait a moment, please. 7. Each proton-bound electron motion forms makes joint motion with each proton's axis conjunction. And these conjunctions of protons have up and down directions as joint cycling. 8. Each proton-bound electron motion form is positioning in side-by-side neighbor protons axis. So, there is one proton-bound electron motion form per each proton. But all proton-bound electron motion forms are intertwined in general picture.